Hey everybody, so we are going to check out equations that look like this, and you're thinking, holy macanoli, not sure I can do that. And the answer is, yes you can. And we're going to use a little technique called U Substitution. And really what that means is, as I look right at these x's here, I'm thinking, oh my word, those are gross. I'm not exactly sure what to do with x to the 2/3 and x to the 1/3. And so we're going to kind of take those out and substitute something else in that makes it look a little bit nicer and easier to solve. And then we'll come back and find real answers. So as I look at this one, I'm going to say, I'm just going to define some variable u, and that u equals x to the 1/3. You might be like, well, why would you choose x to the 1/3? Because if I choose x to the 1/3, and I plug that in right here and right here, then I really get 5u to the 2/3, or no, 5u squared, because x to the 1/3 times 2, that gives me 5u squared, plus 11u, and then plus 2 equals 0. And that's not so bad to solve. So how would I solve that? Well, I break it down, break the outsides down. I know that the only way to make 2 is 1 times 2. The only way to make 5u squared is 1u and 5u. Okay, so I'm going to multiply them. That did not work. Do you see the mistake that I made? And that's totally fine. Not a big deal. If I make a mistake, then I just take them and I turn them around. So when I do that, I get 2 and... All right, now I think I'm back to right. So this gives me 10u and 1u. I add those up to get 11u. Yes, got it. Okay. So first number, so u plus 2 and 5u plus 1. I know everything has to be plus 1. Or I mean plus because of my signs. Okay, so now I keep going. So I know that this u has to equal -2. And this u has to equal -1/5. So if you're like, why? Because if it's equal to 0, minus 1 divided by 5. Okay, but this is not my solution. I just know that u is -2, and u could also maybe be -1/5. So let's now go back up and say, what was u standing for? X to the 1/3. Okay, so now I'm going to substitute that in. So x to the 1/3 power equals -2. And how do I undo 1/3 power? The third power. Got to have parentheses. So x equals -2 times -2 times -2, -8. All right, there it is. Okay, let's check over here. So I'm going to do the same thing. U is x to the 1/3. And that equals -1/5. So I third power it, and so x equals -1/125. And so then I can take those things, plug them back in up here, and I find that, yep, they're actually going to work out for me, and that is going to be a great thing. Okay, let's try another one, because this one looks a little bit more interesting. Do you see how you've got an x and a square root of x? Ugh, I don't want to do that. So let's say u is going to equal the square root of x. Okay, so then if that's the case, let's go in and rewrite. So I've got 2 times x. Well, that's just u squared. Woohoo! Minus 7u. You're like, why'd you put that parentheses? I don't know. Just seemed like a good idea at the time. Minus 30 equals 0. So I pull that apart. I get 2u, 1u. Then over here, what's going to work? 1 and 30? No. 2 and 15? No. 3 and 10? No. 5 and 6? Yes. Okay. So 6 and 5. So that gives me 6 U's. Dang it. Nope, that wasn't right. So, see, look at it. I make mistakes all the time. No big deal. Just erase. But those are the right things. So I think I want the 6 here and the 5 here. Yeah, that will work. So I get 5u, 12u. Does that give me 7? Yep. If the 12 is the loss, the 5 is the plus. Minus the plus. Okie dokie smoky. So now I'm going to rewrite that. So I've got 2u plus 5 and u minus 6. Those equal 0. Okay, so I know that u is going to be equal to this one, negative 5 halves, and u is going to equal 6. Okay, what was u originally for? It's the square root of x. Okay, so square root of x equals negative 5 halves. How do I undo that? I square. So I get x equals 25 fourths. Positive. Okay, and then over here, square root of x equals 6. Square both sides. Get x equals 36. Okay. Yahoo. But let's try both of those answers because one of them doesn't work. 36, if I go in and plug that up into the original, I would get, so 2 times 36 is 72, minus 7 times the square root of 36. Square root of 36 is 6 times negative 7, minus 42, minus 30. Yes, that actually gives me 0, so my 36 is a good answer. But what if I went back and tried the 25 fourths? That always makes me a little leery because it's a gross answer, but college, so I mean, stuff being gross doesn't necessarily mean it's wrong. So 2 times 25 over 4. That gives me 25 over 2. Then minus 7 times 25 over 4. Well, square root. Nice. Okay, so the square root of all that stuff is 5 over 2. So 5 over 2 times 7 gives me negative 35 over 2. Then minus 30. Well, that doesn't give me 0. So I know that this one doesn't actually work. It's an extraneous solution. So my only option is x equals 36. All right, one more. I'm going to look at this and I say, oh, wow, look. I've got x plus 3 in both of those things. So I'm going to say that this time my u equals x plus 3. So I'm going to get u squared plus 7 u minus 18 equals 0. Okay, so that breaks into u plus 9, u minus 2. Again, just pause if you're like, what? Just pause it and figure out why I'm right. Okay, so then I know that u equals negative 9 and u equals positive 2. So now I just substitute back in x plus 3 equals negative 9 equals 2. All right, so over here x equals negative 12 and x equals negative 1. So plug those back in to make sure that they work. So if I do negative 12 plus 3, that's negative 9. Square that is 81. Plus 7 times negative 12 plus 3. So that's negative 9. So plus 7 times negative 9. Negative 63 minus 18. Does that give 81? Does that equal 0? The answer is yep. True. Wahoo. So I know that that's a good answer. Now let's check negative 1. So negative 1 plus 3 is 2. Squared plus 7 times Negative 1 plus 3 is 2 again, minus 18. So 4 plus 14 minus 18, does that give me 0? Yes! All right, so everything works. So there's a 10-minute lesson on U substitution. It just is a way to make a problem prettier than it originally was.